Can you see the screen? Is it visible?
Yes, sir, it is visible.
All right, so last time you guys remember that we went through the concept development phase, and in that we have covered three basic aspects: the generation of those concepts, how we are going to select one which is the most suitable one, and how we are going to refine the concepts in an iterative fashion. We have covered in that refinement process two stages, like initial concepts in the case of recurring example of companion robot. We have identified that initially there were a set of concepts presented to the team. There was this healthy discussion on those concepts, and these visual cues are generally the most important starting point to start the conversation. In the designing phase, conversation is very much important because when you start discussing certain concepts, certain aspects, you start the refining process along with it. So what I'm trying to say in this case is that when you have those visual cues, those conceptual sketches presented to the team is going to start discussing it, different aspects of it, different features that must be there, different features that should be there, and different features that should not be there. So in those contexts, in this context, we have identified a process of refinement, but we have only seen two basic iterations. So today we are going to see that after going through quite a lot of iterations, what is going to be the final stage of the concept. So we will see that later today. So, but at this particular stage, you should readily identify that there are three stages corresponding to concepts: generation stage, which is the stage number one; selection. Once you have multiple concepts, you are going to select uh, the most suitable ones. And then you're going to go through the process of refinement. So in this stage-wise fashion, you are going to eventually find the concepts which are going to be prototyped. So last time in this context, we have gone through this process flow multiple times, and you can readily recall that concept, the word concept, is appearing in these three stages. So these three stages are going to be very much important for us. Let me use highlighter over here. So these stages are important for us. The first one is the generation of concepts, then selection, and then we have to test so that we can eventually refine those concepts. So in the overall scheme of things, this is central. Central in a sense you can see in the process as well, that this is right in the middle of the whole process. So that's why I'm going to say that this activity is central to product designing. All right, let's move on. So last time we have seen this first example of a robotic boiling machine, and in that we identified those different concepts, the pros and cons of those were discussed, and then we made use of the understanding of the biomechanical properties of the boiling action. We identified these as the functions, the working principles, the production aspects, the demands that we have placed for the robotic boiling machine, and operational requirements. And we identified that these are going to be the basic criteria, set of basic criteria, which is going to make us select one particular suitable option out of these five options. So in that particular case, we place these demands, we place the weightage corresponding to those demands, and then we, using the expert opinion, using the user feedback, and using our own engineering knowledge, we weight them vis-a-vis each other. And on the basis of that, we identified the option number 5 is going to be the one which has got the maximum marks. So that's why this is going to be selected. And that was the research paper that I mentioned earlier that reports the full proceedings. Then we moved on to the recurring example of the companion robot, and in that we identified that the design problem is already taken care of. Then we moved on to the development of the personas, and out of those personas, one which is the representative persona, that is of Mr. Yang, which is going to define how the user is going to have certain requirements, certain aspirations, certain expectations out of the product, and how we're going to meet those. What are the constraints? How the person lives his life, and out of those, we formulated the story beats. We formulated how, in different scenarios of emotional interaction, in terms of emergency or hazard environment, how to avoid that, and different aspects were covered in those story beats. So, out of those story beats, we identified the features of the product. So in this kind of fashion, we have already identified that what is needed to be done. And in that particular case, we have identified the 2 iterations of the companion robot, which corresponds to how these parameters are taken care of. The first one being related to emotions, where the robot is required to detect the user's emotion, and it is also able to communicate in terms of having a responsive and empathetic response to uh, the user. It is going to be able to communicate. On top of that, the voice interaction was discussed as well. So this corresponds to the class of emotions. Then corresponding to activities, we identified that what is needed to be done. The robot monitors users' activity, how it moves from one place to the other, what tasks it performs, and so on and so forth. And it is needed to keep track of all those activities as well. And then out of those activities, it has to look for patterns. And if anything goes out of the pattern or turns out to be anomalous, it is needed to be identified and reported to the doctors. And then we moved on to the hazard avoidance, and in that, the robot is asked to detect all the potential hazards. It tries to prevent accidents by having a communication with the person. The robot assists in the case of an accident. So these were the requirements of the design. So this was kind of a brief which defines how this whole activity is needed to be completed. And then we went through quite a lot of sketching, different types of sketches were put forth. Every sketch was discussed in much more detail. Every aspect, every feature was carefully discussed and addressed, and all the pros and cons were identified as well. And in that iterative fashion, we said that once we have the first set of sketches, why not we move on and identify what is further needed to be done, and what is needed to be tried, and what is needed to be avoided. So in this particular case, these are the must-haves, these are the should-haves, and these are should be avoided. All right. So these are the kind of refinement parameters which are going to further refine the whole process. We went through that, and quite a lot of different sketches were presented in front of you, different shapes, different sizes, and every sketch was trying to address the problem that was identified in the first iteration. And once you have gone through that, and you have gone through a number of times in that kind of activity, you gradually start improving the concepts. And in that iterative fashion, you identify what is the technical difficulty in one particular concept, what is the viability, and you discuss quite a lot of different aspects, mainly technical, and then design related, and all the other aspects. But once you have gone through that process of improvement, you are going to have a particular uh, set of uh, final designs, which I'm going to show you today. But before we go through that, I should also make you emphasize that in terms of this care companion robot that was being designed over here, we have to see that the robot is considered to be a robot which has got evolving personality. Evolving personality means that when you start this robot and you unbox it for the very first time, it is going to be a base version of the robot. But when you gradually improve it and give you the time, give the robot time, it starts developing. And it starts developing in a sense that uh, gradually the behaviors are evolved, and out of those behaviors, you are going to see that quite a lot of artificial intelligence is at play in the background. So how that set of behaviors are going to be evolved, this is something like in the phase one, it is just like a care robot. And when you give this robot a time, it develops itself into an acquaintance. A person, the person who's using it, start establishing some relationship with that product. So that is the stage two. And when these behaviors are further evolved on the basis of reinforcement learning, the robot evolves into a friend. A friend is going to be more than the acquaintance. Friend is going to be someone with which the person shares something, some emotions, some feelings, and conversates and discusses certain aspects of life. So it evolves into a friend, and when it further evolves, it evolves into a companion. So starts from a care robot, and then eventually gets evolved into a companion robot, and that is how the evolution of the care companion is mapped over here. And the purpose is that in the starting phase, the robot and the persons both are going to be independent from each other. But then when the 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 robot gets into that evolution, it starts that interaction which is interdependent with the user. And in that particular case, all the primary features, different interaction styles, all the capabilities were listed as well. We have already discussed those, need not to be overly spending time over here, but you can see that over here, all those aspects that we identified in the story beats are indicated. Voice user interface, spillage detection, fall detection, sleep monitoring, emergency alerts, all these topics were identified in the story beats. And then something when it gets evolved, it has got a further refinement of the behaviors, and you can see that it has got the personalized emotion detection. It has got the symptom mitigation aspects to it, which is an evolved personality. And when it gets further evolved, you can see that humanized voice interactions, personalized conversation, contextual reactions are also added to the mix. So these are the capabilities of the robot, which gets evolved with the passage of time. Now, moving on, we were discussing something corresponding to how these concepts are evolved into a product shape. And over here, you can see that you have line sketches. You can see all those lines. And then you can see that on top of those lines, we have started using software tools to build this whole uh, uh, outer shell or the form of the robot. Now, I should also emphasize once again that we have discussed form and functions altogether in the previous discussions. So, from a sketch, which is a 2D, you have to give the form which is a 3D form. So this particular exercise that you can see over here is something that you have sketches, 2D sketches, then transformed into using softwares, transformed into 3D shapes. So when you get into that process, you need to have multiple viewpoints of the product in front of you. So sketching is going to be required in a sense that you have multiple viewpoints made. So the team was continuously drawing sketches, and eventually we went into that phase that we thought that now it is time to get into the 3D mode, and that was what we developed. But out of that, I'm going to now discuss in different aspects how the evolution into the final stage. So from expression standpoint, quite a lot of different phases were identified, taking cues from how cartoons, how characters, how animated characters are developed, taking cues from the existing products as well. So quite a lot of different sketches were made and then transformed into a 3D set of uh, models that you can see over here. So you can see at this particular stage, there are four different uh, models. One which has got a rounded shape, one which has got kind of a different uh, complex shape, should I say? One which has got a rounded face but has got the screen which is rectangular over here, and the fourth one which has got the rectangular face and the screen is also rectangular. So you can see that every iteration has got different aspects, different meaning, different visual impact presented in front of you. The round shape gives different aspects. The complex shape gives relatively different aspect. This one is from practical standpoint because most of the screens are generally rectangular. So we were kind of trying to fit that one in a round shape, and then you can see the other iteration as well. So all these iterations where expressions were needed were sketched, were mapped into the 3D shapes, and then eventually presented to the team, seeking their opinion that which one is the most suitable one to have all those capabilities and features that we have already listed fulfilled. There was quite a lot of healthy discussion on it, that what expression suits the best and what is need to be thrown away. And out of that, uh, we selected this one, right? So these are kind of out of those four options, the one that was uh, making more noise. So these expressions, I should also emphasize that you have to see that not only the face and the overall visual appearance is important, but because it has to exhibit emotions, it has to connect with the person at at in an evolving personality, as we have already discussed, at emotional level. So for that reason, it must have the ability to exhibit or express all those emotions. So currently we are in our final year as well. We are developing one robot face which has got the expression mimicking capability to it. So once you guys are going to visit the final year exhibition, kindly have an interaction with the group to see that what they have done and how they have done it from a product development standpoint. Moving on. So one aspect that I've discussed is corresponding to expressions. But expressions alone is not going to be the only feature in the product, right? You need to have certain technological aspects covered as well. And for that, the size is the starting point. So one needs to identify that what is going to be the appropriate size of the robot, which can move inside the apartment and which can have a meaningful interaction with the person, whether the person is standing, sitting, or lying on the bed. So for that reason, different sizes were presented. Quite a lot of discussion was originated, considering because in this particular case it was primarily meant for the Chinese population. So all the conventional average size of Chinese persons, elderly especially, we identified that what is going to be the most suitable size of the product. Similarly, The width is important in a sense that the robot has to pass through the doors, narrow corridors. It has to move around the apartments. It has to kind of interact with the elderly, whether the elderly is on a wheelchair or standing up or sitting on a sofa. So it must have the size, it must have, in terms of height as well as width, appropriate parameters so that it can freely move around. It, it doesn't create a major hurdle, and it interacts with the person in an effective way. So that was discussed, and the nominal parameters were identified. And the base size, if I recall correctly, it was 400 millimeters. The height was 3 feet. So that was discussed as the finalized height. And moving on, because we have already discussed the expressions, but we have not discussed the capability of this head to have movements. Our own head, if I uh, draw your attention on it, if we observe, we can look up and down. So this is called the tilt, and then you have the pan movement, which goes sideways. So you can have the tilt axis in front of you, which allows the robot to look up and down, and the pan axis, which allows the robot to look sideways. So from left to right, it can have a swivel around this axis. So these 2 degrees of freedom on the neck is going to allow the robot to have a movement and observe what is happening around the robot, which is obviously necessary in this case because the robot has to have sensors like depth camera and all that in order to identify where the person is, and it has to interact on the basis of that. So tilt and pan axis were discussed, and the extent of freedom over there in terms of how many degrees we need to have the tilt and how many degrees we need to have the pan. So that was discussed. Then on the base, it was discussed that we need to have the differential drive arrangement where you have 2 motors. Both the motors, if move at one speed, the robot has to move forward or backwards on a straight line. But when these 2 speeds are different from each other, the robot can rotate, move around, or change the orientation. And on top of that, these motors are needed to be driven, so you can see the motor drivers and the controllers over there. The air vents are placed over there, exhausts are there, and then quite a lot of other sensors, how we are going to place them. The sonars you can observe, the IR sensors, you can observe those. The cliff sensors are also indicated. So quite a lot of discussion went into how the base is designed and how we're going to have all those different capabilities which allows the robot to have movement or navigation inside the apartment was discussed. On top of that, the clearance is really important because the robot has to move inside the apartment. So how those apartments are structured generally, what are the hindrances, if there is a carpet, what is the height of that carpet with which it has to handle, and on the basis of that, there was quite a lot of discussion that what is going to be the most appropriate clearance with the ground. So it was discussed that we're going to keep it at around 2 inches. Uh, as you can recall, the guys who were present last time, the center of gravity was also an important aspect. So there was one feature in the initial phases that was discussed to be like asking the robot to have a tilt forward or backward kind of arrangement. But after quite a lot of deliberations, it was identified that it is going to force the robot's center of gravity to come out of the envelope, and it is going to eventually, possibly, make the robot unstable. And because this is an environment where elderly is there, the person is not going to be that healthy. So for that reason, it is really important to not allow that kind of uh, instability on the robot. So for that reason, there was quite a lot of discussion, and on the basis of that, the center of gravity was decided to be kept as low as possible. So quite a lot of analysis was performed. One analysis is there where you can see that center of gravity lies well below the central line. So you can see that it is going to remain stable in different conditions. Obviously, nothing can be made foolproof, but generally speaking, if you keep the center of gravity as low as possible, the robot is going to be much more stable. And on the basis of that, and all the other discussions on the technical aspects, there was one aspect which is very important, that is called design for assembly, or design, or DFA. There is another aspect which is called design for manufacturing. But in this particular case, you can see that design for assembly aspect is being presented in front of you. So there was quite a lot of discussion that how you're going to have all these components manufactured, what is going to be the nominal sizes of the machines on which these are to be manufactured, what is going to be the material, how we're going to do that, and quite a lot of stuff was discussed. And on the basis of that, different proposals were presented that this is how we're going to have different panels made, and then we're going to assemble them together. So assembly lines were identified, the joining lines were identified, the fastening methods were identified, and quite a lot of other discussions went into that. So this is one of those sketches where the assembly possibilities were discussed. So this is one of the options. The one which has got lesser number of components is over here. So every aspect was discussed in quite a lot of detail to see that what is going to be the DFA or DFM aspect of the design. And then obviously we have to place certain cameras. In this particular case, the robot has to perform an activity in an apartment. So some things are going to be much nearer to the robot, some things are going to be much farther from it. So you need to have some sensor on the robot which allows that sensing around itself. And either we can have a lidar placed where you have a laser-based sensor which maps the environment around the robot. Or recently there are quite a few cameras like Intel RealSense cameras are quite popular nowadays. Similarly, Azure Kinect and Microsoft Kinect, and there are quite a lot of other manufacturers who are developing these depth cameras, which allow you, in a sense, that you can have the task of the camera taken from it, conventional camera like RGB camera, and then you can have the SLAM or simultaneous localization and mapping done using those cameras as well. So mapping on the basis of depth sensing and conventional camera on the basis of RGB sensor in it, you can have quite a lot of functionalities combined into a single package. So we identified that we're going to place a depth camera over there. How are we going to place that? What is the ideal location of it? How are we going to cover it so that it remains protected? And in order to see that how the field of view is needed to be uh, made sure on the basis of having the extent of tilt axis indicated. So you can see that this is indicating the field of view as well. So these technical details were discussed as well. But one technical detail which demands quite a lot of deliberations is joint dynamics. But before we get into that, let me show you what we have discussed so far. I'm going to jump back once again in the technical aspects, and just like a quick recap, in the technical aspect, we identified the size. Size means the height and the overall width, the form factor, corresponding to the use case scenarios. We identified that we need to have some degrees of freedom on the head. How are we going to do that? So quite a lot of technical discussion went into that. The robot has to move around in an apartment, have the autonomous navigation. How that is going to happen? You need to have a mobile base to that. So this is indicating that. And you have to see the environment, how the robot interacts with the environment. So quite a lot of discussion went into that. The one which is displayed in front of you is the ground clearance. The center of gravity is an important aspect. We identified that we're going to keep it as low as possible. So that technical aspect was discussed as well. And then design for assembly and manufacturability. So that was discussed. And then how we're going to attach those sensors and what type of sensors are going to be needed and what is going to be their field of view, especially in this case for the depth camera. So these were technical aspects. I've shown you just like the sketches, but there was quite a lot of technical detail, technical specifications, uh, some formulation in the background. I'm not going to discuss because this is what you have already discussed in other courses. Like for example, you're studying the robotics course, and in that you must have seen that how the robots are modeled, how you're going to have the path planning done for those, how you're going to have the autonomous navigation for those, what are different algorithms. You have already studied those, I'm sure of that. That detail, technical detail, where you have all those formulations, I'm not going to discuss over here because this is already discussed in other courses. But the ones corresponding to the form factor, corresponding to the design, these were the major aspects of the technical domain. But the one that is yet to be discussed is joint dynamics. Now, uh, there was this screen in front of the robot. There's one screen which is corresponding to how the face is indicated. So that is the expressions. That is the face of the robot. But there was one challenge over there, that are we going to uh, remove the facial expression or face from the screen above on the head and place certain textual or other user interfaces on this screen, or alternatively, we need to have a dedicated screen for the robot on the torso, which allows the robot to have the interaction with the person by allowing some Android or other devices to the person. So if the person has to make a phone call, the person needs to access the address book or the contact list. So that is not going to be displayed on the face, that is going to be displayed on the screen. So there was quite a lot of discussion, and eventually it was discussed that yes, we are going to have the screen on the torso, so that the robot always keeps the facial expression active, so that the interaction is not a machined interaction, but it is something like an emotional interaction. So coming back to the point, so this screen is on the torso. Torso, the placement is such that the screen is uh, below the 2 feet height. So for that reason, the screen has to have certain angle to it, so that it gets easier for the person to interact with. So we discussed that we are going to have some sort of pivoting action on the screen, which allows the screen to have a tilt. So how that tilt is going to be placed, so that was discussed. One possibility is to have the fixed pivot. One is going to have a fixed pivot over here. One is going to have kind of a sliding pivot placed over there. So there was quite a lot of discussion on that. Similarly, the arms, or we call them flappers, because these are not full-fledged, fully working arms. These are just like simplistic arms, which is going to help the robot to express emotions. It is going to have for example, if the robot is feeling happy, it has to flap them and stuff like that. So these are not the full-fledged robotic arms, but it is just like a knockdown version of it. But we thought that in order to have the robot to exhibit all those behaviors at emotional level, it needs to have some sort of arm movement. So how that movement is going to take place? You need to have some sort of mobility corresponding to these shoulder joints. So we discussed that we are going to have 2 degrees of freedom over here. So for that reason, it can have a movement up and down, and it can have a sideways movement as well. So how that is going to fit? So there was quite a lot of concepts were discussed, and different uh, aspects are in front of you. So we have discussed the leaning aspect, considering that the center of gravity was kept over there. So this was discussed, that how we're going to, what is the extent of that leaning movement over there. Corresponding to those joint movements, joint dynamics, there was quite a lot of discussions in the background. there was this mathematical model that was made. There was one model made in SolidWorks in order to see that what is going to be the inertial factors corresponding to those joint movements when the robot leans forward and stuff like that. So that kind of joint dynamics was also discussed. फिर आगे बात करते हैं charging dock की. The robot, when it moves, it has to consume energy, and when it consumes significant energy, it has to go back and charge itself once again. So in general modern robots, this is just like a standard norm that the robot finds its way back to the charging dock and docks itself automatically, and charges itself, charges the batteries. So for that reason, we need to have that kind of arrangement. For that, the charging dock was identified, the sensors that are needed to be there, how the robot is going to align itself. So that was discussed. So there was quite a few variants. So those were discussed eventually. This was finalized that we're going to have this as the charging dock, which has got some sensors on the charging dock, and a few sensors on the robot are going to allow the robot to have movement. And on top of that, uh, the LED indication was also discussed, that you are going to change the colors when the robot is charging itself, and when the robot is in the operational mode, the colors are going to change. Then corresponding to the outer shape, there is quite a lot of discussion on materials and textures, because the robot should not be uh, should not be considered to be something like plastic, because we are going to allow that personality to evolve. Sorry, मैं थोड़ा सा rephrase करता हूँ. Can you recall that in the starting phase we discussed that the robot has to have evolving personality? So if there is a plastic product in front of you, you would never assume that this product is going to evolve like a personality. You need to have the texture, the skin, the outer shape, corresponding to kind of a living organism. So for that reason, it was really important to identify the corresponding materials and textures. On top of that, this is a care product to start with. A care product should be hygienic, it should be easy to clean and stuff like that. So for that reason, materials are needed to be well taken care of. So this was kind of a challenge, that are we going to have too soft outer skin, or are we going to have too robust plastic-like skin? So obviously, the decision was made right in the middle. We need to have a soft, hygienic, durable material which serves the purpose. And so for that reason, there were quite a lot of deliberations, and eventually this material uh, was selected. User interface is also an important aspect. Let me jump, because we have identified material somewhere over here. Let me see that. Yeah, over here. So this is called Alcantara, the material that I was discussing. Jumping back, so we were over here. So we opted for this material, which is easy to clean, which is soft, and which is hygienic as well. And moving on, user interface. Now, not only the screen that I've discussed, the face has got a screen as well, and how that face has to exhibit different emotions of joy, happiness, sadness, and other emotions. So there was quite a lot of sketching done to see that what is the most appropriate uh, 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 shape and form factor. And eventually, quite a lot of prototypes, paper prototypes were made in order to see that what is the most suitable one. And eventually, we went into uh, uh, testing mode, and quite a lot of these storyboards were presented in front of the audience. And you can see one storyboard like that. Over here, you can see that uh, the camera is placed down there. The screen is structured in a sense that it envelopes everything except the depth camera. Over here, you can see the slight variation. Screen is there, but you can see that it does not uh, uh, embraces the sensor over here. So this is different from here. And over here, you can see that the camera is placed on top, so it is flipped, and you can see a variant over there, you can see another variant. So there was quite a lot of variants discussed, and then how those emotions are going to be exhibited. So quite a lot of variations were discussed in that as well. Um, so you can see quite a lot of variations over there. Moving on. Interaction is important. Interaction, how user interacts with the robot, the screen on the face and screen on the torso have been discussed. But on top of that, how you're going to have the microphones placed, how you're going to have the speakers placed, so that the voice interaction can take place. How you're going to allow the robot to turn itself on, how you're going to turn it off, what is going to be the brightness level, and stuff like that was also discussed. There was quite a lot of discussion that how you're going to have different controls presented to it. So quite a set of different variants were discussed. Eventually, this was transformed into a much more simpler on-off button. But initially, the discussions were something like that: how you're going to have this button which allows the user to have brightness control, mic control, volume control, and stuff like that. Interactions not only are going to be on the basis of voice interaction, but visual interactions are there, but how the robot exhibits itself when it is talking, when it is paying attention, and how different aspects like internal emotions, internal feelings are exhibited. So quite a lot of variations were discussed in that line. All right. So on top of that, as it is really important that the whenever you have a product which interacts with user, there is a very big area which is called user interaction or UX. In the product design paradigm as well, interaction or UX is altogether a very big field, and in that, all the apps that you're using on your smartphones, all the different softwares that you use, all the different websites that you find attractive, they have a very big team dedicatedly working on improving the user experience. And for that reason, it is really important for this particular robot as well to identify how the user has to interact with the device. These parameters are indicating those aspects. We need to focus on engaging onboarding. We need to have the emergency scenarios handled. We need to address the news feed because elderly are more inclined towards getting to know what is happening around them. From social side all the way to the political side. The Considering these are elderly people, so you need to have the size of those icons and all that uh, uh, enlarged as well. So that aspect gets into there. The communication facilitator role is needed to be placed on the robot as well. So that is also an important aspect of the user experience. So these were discussed, and quite a lot of different aspects were discussed as well. So covering all those aspects, this final concept is over here. Just observe it for a while, and then we're going to move on. You can see the face, you can see microphones, depth cameras, expression display. You have microphones over here, an array of microphones to be precise. You can see the neck now. This neck has got the ability to tilt and pan. You've got the speakers over here, duplex arrangement, so that in a meaningful way the product interacts. You can see the skin, you can see how it is wrapped around the final shape. You can see the interactive display, which has got the user experience inside it. You can see the SLAM sensor, simultaneous localization and mapping sensor. You can see all those LEDs. And you can see the air vents, You can see the Docker, you can see the response lights, and quite a lot of other detail as well. So this was the final concept made, which we decided to get into the prototyping stage. I will discuss prototyping in next couple of lectures, but that is altogether a different topic, so we will discuss that later on. So there was quite a lot of visuals made, and the basic idea in this particular exercise was that once we have finalized the design, we are going to have a prototype made, and we're going to have another prototype made once again, improving it further. And once we have a minimum viable prototype in front of us, we are going to get interacted with the investors to seek investment in the product. So for that reason, a pitch deck was also being prepared as well. So maybe if we find time, we are going to discuss that later on. But at this particular stage, you can see that all these concepts that you can see in front of you have been developed in an iterative fashion, spending quite a lot of time on it, covering all those technical aspects that we have discussed, covering all those aesthetics aspects that we are covering, and utility aspects. Once we have gone through that exercise, we are going to get into the prototyping stage. So that's where we are heading. We are going to discuss that eventually in the next lectures. But at this particular stage, just see that how we're going to have the final shape, final concept presented after an iterative process of concept development. All right, so this is just like a glimpse. There are numerous other aspects that I've skipped, some because of intellectual property concerns, and some corresponding to because the discussion is going to be dragged much if we discuss all those aspects. But believe me, there's quite a lot of time spent by a big team on this concept development, and there's quite a lot of computations and formulations that are happening in the background. So you have just seen the glimpse of it, but you would still know that there are quite a lot of things to be handled in this particular product. For example, just to give you an idea, there's quite a lot of this expandable architecture that we spend much time on it, that how we're going to have the hardware layers, the middlewares, the firmware, how that is going to take shape, the network layer, and stuff like that. So there's quite a lot of things that are at display, and quite a lot of different journey maps were made as well. But at this particular stage, let's talk what we wanted to talk in this lecture. And that is that now when you have seen this whole process of concept refinement, now you have to do the refinement of your concepts corresponding to the semester project that you have already selected. तो आप लोगों का जो भी आपने select किया है individually एक design problem, एक product design के context में semester project, आपने उसकी refinement करनी है इसी तरीके से जैसे कि मैंने आपके सामने चीज़ों को present किया है. You have to see in an iterative fashion कि आपने पहले कुछ sketches बनाए, फिर आपने उसे improve किया, अब आपने उसको 3D मॉडल करना है. आपने ऑलरेडी SolidWorks के अंदर काम किया हुआ है. अगर कुछ लोगों ने कोई दूसरे सॉफ्टवेयर्स किए हुए जैसे कि let's say कि Autodesk का Fusion 360 is a very good online software, you can use that. किसी ने अगर 3D Studio Max में किया हुआ है उसमें कर सकते हैं. There are quite a lot of other softwares as well जो कि आप यूज कर सकते हैं solid modeling के लिए. So what I'm going to ask you to develop 3D models, refined 3D models of the semester project that you have already selected. ये आपने करना है. अगले एक वीक में इसका पहला वर्जन हमारे पास आ जाना चाहिए आपके हर एक सेमेस्टर प्रोजेक्ट का, और वो आपने सबमिट करवाना है. मैं आज एक असाइनमेंट के तौर पे उसे करूंगा, लेकिन चूंकि ये दिस इज पार्ट ऑफ द प्रोजेक्ट, This would not be treated as a separate assignment. This would be eventually uh, merged into the final project report. लेकिन वो मैं ये चाहता हूँ कि एक वीक के अंदर ये एक्टिविटी आप मुकम्मल कर लें और आप सबमिट करवाएं इसको. It would not be the final submission of your project. It would just be the submission of the 3D model जो कि आपने सबमिट करवाना. उसकी आज मैं प्लेस कर दूंगा उसकी डिस्क्रिप्शन. आपने उसको एक वीक के अंदर मुकम्मल कर. Any queries on that?
Assalamu alaikum, sir. Sir, is it necessary to update you that we have changed our project? Like मैंने जो पहले किया था उसमें सर एक helmet था and that was like quite complex to make in a semester project. So I'm willing to change that into another useful thing. So is it necessary to email you about it?
Look, uh, what my suggestion would be, I cannot really dictate terms over here. What my suggestion would be that once you have decided that this is going to be your semester project, never get down from here, from there. Or let me rephrase that. इसमें होता ये कि इंसान अपनी ज़िंदगी में कुछ ऑब्जेक्टिव्स बनाता है और वो जो ऑब्जेक्टिव्स होते हैं उसके पास दो रास्ते होते हैं. उनकी कोशिश करे उस ऑब्जेक्टिव को मीट करने की या उस ऑब्जेक्टिव को अपने मुकाम से हटा के एक छोटे ऑब्जेक्टिव के ऊपर आ जाए. नेवर डू दैट. ये जो दूसरी ऑप्शन है कि आप जब ऑब्जेक्टिव को नीचे ले आते हैं, ये कभी ना कीजिएगा ज़िंदगी. ये मैं आपको तो कह रहा हूँ लेकिन मैं अपने आप को भी सुना रहा हूँ. इसलिए सुना रहा हूँ अपने आप को भी कि once you start kind of reducing your objectives, ये फिर एक endless process होता है. आप जिंदगी में जो भी टारगेट सेट करते हैं आप उस टारगेट को फिर डाइल्यूट करने लग जाते हैं. उसको सिंप्लीफाई करना शुरू कर देते हैं, उसको छोटा करना शुरू कर देते हैं. नेवर डू दैट. अगर आपने शुरू में सोचा
Sir, actually,
है, मैं आपको बात जो मुश्किल है उसको हम हैंडल कर लें. लेकिन अगर आपने हेलमेट बनाना है तो उस हेलमेट को बनाएं. आपको मसला ये होगा कि मैंने उसे बाद में 3D प्रिंट करवाने कैसे करवाऊंगा. 3D प्रिंट ना करवाएं आप उसको मे बी आप उसको एक उसका वुडन कोई मॉडल बना लें या जैसे स्टायरोफोम का बड़ा ब्लॉक लेके उसमें से उसको एक्सट्रैक्ट कर लें. So there's quite a lot which can be done to find ways जो कि आपको टेक्निकल डिफिकल्टी आ सकती है.
sir, actually, uh, I want to request you that. Sir, actually,
एक बात करूँ मैं सिर्फ ये कहना चाहता हूँ कि अगर कोई फाइनल सेट ऑफ फीचर्स सारे के सारे उसके अंदर नहीं भी आते जो कि आपने सोचे थे शुरू में, आप कुछ उसके रिड्यूस्ड फीचर्स प्रेजेंट कर दीजिएगा जो कि आप समझते हैं कि प्रोटोटाइप करने ज़रूरी है. कुछ ऐसे फीचर्स होते हैं जिनको प्रोटोटाइप करना ज़रूरी नहीं है. ठीक है, उनको आप रहने दें लेकिन keep the project as it was first.
सर बेसिकली जब आपने कहा था ना कि उसी प्रोजेक्ट को जो आपने सबमिट करवाया है एक असाइनमेंट सबमिट करवाई उसी को आपने सेमेस्टर प्रोजेक्ट बनाना है. आई हैड नो आइडिया दैट इट्स गोइंग टू बी माय सेमेस्टर प्रोजेक्ट बट दैट वाज क्वाइट रियली बिग. लाइक ये फाइनल ईयर प्रोजेक्ट के लिए भी मतलब सूटेबल चीज है. दैट्स व्हाई आई वाज सेइंग दैट.
Even if you submit nothing, it doesn't make any difference to me. What I'm trying to say is, what is your what is going to be your decision? Don't ask me. Ask yourself. If you feel that is too big for that particular semester and the remaining time that you have got in this semester, change it. No worries. I don't have any kind of expectations from anyone from the class that the submitted project is going to be wonderful and I'm going to be amazed. If I'm amazed, I would show my emotions. I'll appreciate you guys. I'll say that shabash, you have done really wonderful work. Even if, but because this is your own project, uh, you have to decide that what is going to be the extent of work that is to be submitted. ठीक है, जैसे क्लास में आना या ना आना मेरे लिए कोई बहुत अहमियत नहीं रखता आपका. हाँ, ये अहमियत मुझे जनरली मुझे ये कंसर्न ज़रूर होती है कि अगर आप क्लास में नहीं आएँगे तो बहुत सारी ऐसी बातें जैसे अभी हम इंटरैक्ट कर रहे हैं वो नहीं हो पाएँगी। अ, तो ये मुझे कंसर्न होता है, लेकिन दिस इज़ योर ओन डिसीजन, भाई आप क्लास अटेंड करना चाहते हैं या नहीं करना चाहते। ठीक है, इसी तरह से ये आपका डिसीजन है कि आप प्रोजेक्ट कौन-सा करना चाहते हैं, किस हद तक करना चाहते हैं। जिस हद तक आप ले गए, अगर वो उस पे मैं खुश हुआ, मैं खुशी का इज़हार करूँगा, अगर मुझे अच्छा ना लगा तो मैं उसकी नाराज़ी या नाखुशी का भी इज़हार करूँगा, बट विदाउट काइंड ऑफ हैविंग अ जजमेंट ऑन यू, or only I'll judge the project or the submission that you have done. I would never judge the person. मैं इसलिए ये बातें इसलिए कर रहा हूँ क्योंकि आपके सवालों के पीछे एक उसका एक सब कॉन्शियस लेवल के ऊपर एक कुछ थॉट प्रोसेस होता है, तो मैं उसको भी एड्रेस करना चाहता हूँ। आई एम गेसिंग कि शायद इस तरह के एस्पेक्ट्स आपके लिए इम्पोर्टेंट हो, तो इसलिए मैं कह रहा हूँ। ठीक है, आप करेंगे बहुत अच्छी बात है, आप नहीं करेंगे कोई ऐसी बड़ी बात नहीं है। ठीक है, लेकिन वैसे जनरली आई वुड से कि हाँ, आप कोशिश करें, आपने जो ऑब्जेक्टिव बनाया है उसको फुलफिल करें, भले उसके लिए आपको ज़्यादा टाइम स्पेंड करना पड़े, कोशिश ज़्यादा करनी पड़े, करें, आप ज़रूर करें। ठीक है?
Okay, okay, sir. Thank you so
Okay.
much.
Anyone
And sir,
else?
one more thing, sir, I want to remake that toy, and can I submit you in the end of the semester? I want to remake my toy.
बना लें।
Okay, thank you, sir. Thank you.
Anyone else? On today's lecture, is there any query that you've got?
Assalamu alaikum, sir. Sir, मेरी क्वेरी है रिगार्डिंग जो सर आपने ये पूछा था कि जो इसकी आउटर स्कीन है वो हम एल्केट्रा से बनाएंगे। सर एक्चुअली जो मेरा क्वेश्चन था वो ये था कि हमें किस तरह लाइक अब ये जो मटेरियल है इसका नेम मैंने आई थिंक सो फिर फर्स्ट टाइम सुना कि ऐसा मटेरियल एग्जिस्ट करता है। सर हमें किस तरह पता चला है कि हम लोगों ने कहाँ पे किस टाइप का मटेरियल जो है वो अप्लाई करना है।
असल में होता है कि जो हमने आपको ये तो अंदाज़ा है कि हमारे यहाँ यूनिवर्सिटी के अंदर भी एक प्रोडक्ट डिज़ाइन का पूरा डिपार्टमेंट है, और प्रोडक्ट डिज़ाइन की एक डिग्री यूनिवर्सिटी देती है। वो 4 सालों में क्या करते हैं? 4 सालों में जो बहुत सारी चीज़ें वो सीखते हैं, उसके अंदर एक एस्पेक्ट मटेरियल्स का भी है, और वो मटेरियल्स बहुत सारी डिफरेंट वैराइटीज़ में, बहुत सारे डिफरेंट टेक्सचर्स में, बहुत सारे डिफरेंट जो उसकी विजुअल अपील है, कलर्स में, उसको वो डिस्कस करते हैं, उसकी कैरेक्टरिस्टिक्स देखते हैं, उसको उसकी ड्यूरेबिलिटी, उसका यूज़, उसकी फॉर्मेबिलिटी, ये बहुत सारी चीज़ें बहुत डिटेल में देखते हैं। अनफॉर्चुनेटली ये जो हमारा सेमेस्टर लॉन्ग कोर्स है, इसके अंदर बहुत सारे ऐसे एस्पेक्ट्स हम कवर कर नहीं पाते। एक तो इसमें ये ज़रूर ज़हन में रखें कि हमने जितनी बातें की हैं, मैंने शायद शुरू में भी ये बात की थी कि दीज़ आर जस्ट लाइक कन्वर्सेशन स्टार्टर्स। एक्चुअली होता ये है कि जब आप प्रोडक्ट डिज़ाइनर के तौर पे अपने आप को डेवलप करते हैं, यू डेवलप बाय स्पेंडिंग लॉन्ग टाइम ऑन इट, और वो स्किल्स, वो अंडरस्टैंडिंग, वो नॉलेज आप जमा करते हैं, एक्यूमुलेट करते हैं, और ये एक्यूमुलेशन जो सी है वो 1-2 महीने में नहीं होती, बल्कि 4, 5, 7, 8 सालों में होती है। So what I'm trying to say in this particular case is कि हमारे पास इतना टाइम नहीं था कि हम मटेरियल्स के बारे में बहुत सारी डिस्कशंस करते। तो एक तो ये आपको ज़हन में रहना चाहिए। दूसरा ये कि ये जो डिज़ाइन एक्टिविटी हुई है, ये आपने देखा होगा कि ये कोई एक बंदे का काम नहीं है, बल्कि ये मल्टीपल लोगों की टीम जो कि मुख्तलिफ बैकग्राउंड से आ रही थी। कुछ ऐसे जो कि एनसीए से हैं, कुछ ऐसे जो बीकनहाउस यूनिवर्सिटी से हैं, कुछ उसमें कंसल्टेंट्स थे, इंजीनियरिंग साइड से लोग थे, कुछ काम करने वाले थे, कुछ एडवाइजर्स थे, बिजनेस साइड के पीपल थे। इस पूरी टीम के अंदर बहुत सारे लोग इकट्ठे मिलके काम कर रहे हैं। तो वो जब ज़्यादा लोग काम करते हैं, बड़ी टीम होती है, तो उसमें मुख्तलिफ एस्पेक्ट्स मुख्तलिफ साइड से आ रहे होते हैं। जैसे फॉर एग्जांपल अगर मैं टेक्निकल साइड में हूँ और मुझे पता है कि ऑटोनोमस नेविगेशन किस तरह की जा सकती है, आई वुड बी डिस्कसिंग दैट ऑटोनोमस नेविगेशन विद द डिज़ाइन टीम। लेकिन कोई बंदा ऐसा जो मटेरियल्स के बैकग्राउंड से आ रहा है या एस्थेटिक्स के बैकग्राउंड से आ रहा है या आर्टिस्ट है, वो बंदा बताएगा कि भाई इस तरह की इंटरेक्शन स्किन के साथ, मटेरियल के साथ, इस तरह के मटेरियल्स आप यूज कर सकते हैं। Are you getting the point? So what I'm trying to say in this case that when the design activity is generally performed, you wish to have a team which has got different backgrounds, different trainings, and you assemble the team to come up with that final design. और उसमें मुख्तलिफ एस्पेक्ट्स मुख्तलिफ जगहों से आ रहे होते हैं, ठीक होगी बात। लेकिन बट ऑन टॉप ऑफ दैट आप अब अपने सामने पड़ी हुई चीज़ों को, अगर आपके सामने जो भी टेबल है या जो भी आप चीज़ें देख रहे हैं, उसको भी अगर आप केयरफुली ऑब्जर्व करने लग जाएंगे, यू वुड फाइंड काइंड ऑफ रियली इंटरेस्टिंग कि मुख्तलिफ तरह के मटेरियल्स, मुख्तलिफ तरह के टेक्सचर्स वो कैसे किस तरह की फीलिंग जनरेट करते हैं। आप कभी अपनी वालदा के साथ कपड़ों की खरीदारी पे गए हों, तो जैसे आपकी वालदा चेक करती हैं कपड़े की क्वालिटी को, दैट मे गिव यू अ क्यू। आप अपने फादर के साथ कहीं फ्रूट की शॉपिंग करने के लिए जाएं और उस वक्त देखें कि वो कैसे देखते हैं, इंटरेक्ट करते हैं, चेक करते हैं कि फ्रूट सही है या नहीं, वो कैसे टेक्सचर को आइडेंटिफाई करते हैं, कैसे उसके मटेरियल को, उसके बारे में फ्रूट को बाहर से देख के, छू के आप टेस्ट करते हैं कि क्या वो सही होगा या नहीं होगा। तो इस तरह की चीज़ें जो होती हैं, दोज में गिव यू क्यूज। आप इस वक्त जैसे बैठे हुए हैं, आपकी टेबल, आपके सामने पड़े हुए पेपर्स, फाइल्स, जो पेन आपने पकड़ा है वगैरह वगैरह, इसको देख के आप मटेरियल्स के बारे में अंडरस्टैंडिंग डेवलप कर सकते हैं। So what I'm trying to say is that material is something which is always in front of you. If you open your eyes, you would find it really amusing and really interesting to see how and what are the different types and how different materials invoke different kind of sensation in subconscious level. ठीक है? तो ये जब आप डेवलप करना शुरू कर देते हैं, इस तरह की आंखें खोल लेते हैं, तो आप बहुत सारी चीज़ों को बहुत इंटरेस्टिंग वे से देखना शुरू करते हैं। और वैसे प्रोडक्ट डिजाइनर के तौर पे ये सवाल तो आपको बहुत अच्छा सवाल है, इन सेंस दैट इट हैज ओपनड अप डिफरेंट एस्पेक्ट्स ऑफ द डिस्कशन। ये जहन में ज़रूर रखिएगा कि एक ये जो हमने अपनी ज़िंदगी गुजारने का एक तरीका ये होता है कि आप बहुत सुपरफिशियल लेवल के ऊपर चीज़ों के साथ इंटरेक्ट करते हैं, ऑब्जर्व करते हैं अपने इर्द, बहुत सुपरफिशियल लेवल के ऊपर। और एक ये होता है कि आपके सामने जितनी भी चीज़ें हैं, आप उन सब से मुंसलिक हो जाते हैं, उनसे मुताल्लिक हो जाते हैं और उनको एक डीपर लेवल के साथ अपने साथ एसोसिएट करते हैं। सो इफ इवन at this particular stage, I'm sitting in my room alone discussing these aspects with you guys, but everything which is in front of me, all the chairs, all the cabinets, and all the files, and all the papers, and all the books that I've got over here, I'm deeply invested in that. I've got this deep uh, psychological association with all these objects in front of me, around me. जब आप उस तरह की एसोसिएशन बना लेते हैं अपनी चीज़ों के साथ, then you start enjoying your work, you start observing things in a different fashion. तो जब अगर आप मटेरियल्स की बात करेंगे, टेक्सचर्स की बात करें, तो ये बहुत सारे मटेरियल्स, टेक्सचर्स हमारे इर्द-गिर्द मौजूद हैं, हर लम्हा मौजूद है। हम उनको देखना शुरू कर देंगे, अप्रिशिएट करना शुरू कर देंगे, तो प्रोडक्ट डिजाइनर के तौर पे वो वोकैबुलरी बिल्ड करना शुरू कर देंगे, जो कि आपको कहीं ना कहीं इवेंचुअली यूज होगी। ठीक है? तो इसको ध्यान में जरूर रखिए। प्रोडक्ट डिजाइनर रिमेन्स प्रेजेंट, वो अपने दौर में जिंदा होता है, अपने अहद में, अपने माहौल में हमेशा रिसेप्टिव होता है। तो अगर आप रिसेप्टिव होंगे तो मुख्तलिफ तरह के मटेरियल्स आपके सामने जो आएंगे, हो सकता है आपको बाद में ख्याल है कि यार इस जगह पे वो मटेरियल लगा लेना तो बहुत अच्छा लगेगा। ठीक है? एनीथिंग एल्स?
ठीक है सर, थैंक यू सो मच।
Any further questions on this topic? So let me kind of sum it up. Gigi, go ahead, please.
अस्सलाम सर।
जी वालेकुम सलाम, बताएं।
सर ये जो आपने सॉलिडवर्क्स का बताया, ये फाइनलाइज मॉडल हम बनाएंगे, मतलब कि जो भी हमारा सेमेस्टर प्रोजेक्ट था।
पहले एक हफ्ते बनाए तो सही। फाइनलाइज्ड ही होना चाहिए, लेकिन हो सकता है कि उसके ऊपर मेरी कुछ फीडबैक हो और हो सकता है मैं कुछ इस तरह की एक्सरसाइज कर लूँ कि आपने सबमिट करवाया तो आपके प्रोजेक्ट को कोई और स्टूडेंट इवैल्यूएट करे और अपनी फीडबैक दे और इस तरह से एक इवैल्यूएशन हम इंटरनल इसको जिसको पीयर इवैल्यूएशन कहते हैं वो करवा लें। So
ओके
I've not kind of thought about it, but what my suggestion would be, मैं इसलिए कहना चाह रहा हूँ कि एक आइट्रेशन हम कोशिश ये करेंगे कि उसकी इम्प्रूवमेंट की ज़रूर कर लें ताकि जब हम प्रोटोटाइपिंग के स्टेज में जाएं नेक्स्ट वीक तो आपके पास एक आइट्रेशन ऑलरेडी हुई हुई हो और फिर आप एक प्रोटोटाइपिंग करें, ठीक है?
ओके सर, थैंक यू।
Anyone else? All right, so let me sum it up. What we have discussed today is that in the previous lecture, we went through two iterations. हमने कहा कि पहले sketches, फिर उनकी बुनियाद पे हमने कहा कि ये उसमें कमियां कोताहियां हैं, इनको कवर होना चाहिए, ये must haves है, ये should haves है, और this is what we shouldn't have in the product. And on the basis of that, we did the second iteration. तो ये हमने पिछले लेक्चर में कर लिया, लेकिन मैं अब आपको ये कह रहा हूँ आज जो हमने डिस्कस किया है उसके बाद बहुत सारी इसी तरह की आइट्रेशंस होती चली गई एंड यू कैन अज्यूम के 3-4 महीनों की आइट्रेशंस के बाद इवेंचुअली वी वेंट इनटू दैट फाइनल फेज जो कि आज मैंने आपके सामने एग्जिबिट किया है, जिसमें एक्सप्रेशंस, जिसमें इंटरेक्शंस, वॉइस इंटरेक्शन भी, विजुअल इंटरेक्शन भी, जिसमें जॉइंट मूवमेंट, जिसमें आर्म्स की मूवमेंट है, हेड की मूवमेंट है, बाकी चीज़ें, सेंसर्स की प्लेसमेंट, जिसमें जो मोबिलिटी एस्पेक्ट है वो, और इस तरह के बहुत सारे और एस्पेक्ट्स को डिस्कस किया गया। इस तरह से चार्जिंग कैसे होगी, मटेरियल्स कैसे लगे होंगे, उसके टेक्सचर क्या होगा, इस तरह की बहुत सारी चीज़ें करके हमने जो फाइनल शेप आपको दिखाई है दैट गिव्स यू दैट रियलाइजेशन कि ये प्रोडक्ट किस तरह की फॉर्म में हम विजुलाइज करते हैं। So that is an iterative process. मैं बार बार ये कह रहा हूँ iteration इसलिए कह रहा हूँ क्योंकि आपको कब हमेशा ये याद रहना चाहिए कि आप पहली बार जब attempt करते हैं you never come up with the final solution. You are always willing to listen to the other people, their opinions, their inputs on that, and you're always receptive कि भाई हाँ आप अगले कुल नहीं है, आपने जो बनाया उसके अंदर हमेशा एक इम्प्रूवमेंट की गुंजाइश है और वो आप इम्प्रूवमेंट्स करके इवेंचुअली आइटरेटिव फैशन में इम्प्रूव करते हैं. And after that improvement process, depending upon the nature of the theme, obviously, uh, I've shown you the final product जिसको आपने देखा है कि वो अच्छा visual place कर रही है. I would not say that this is absolutely perfect. I'm not saying it all. But this is an iterative process, and if you believe the process of iterative process, that it evolves, we have evolved the solution to a certain extent. There is still room for improvement, but that is another story to tell later on. लेकिन coming back to the point, तो आज जो हमने देखा है वो iterative process को appreciate करना देखा है और ये देखा है कि iterative process में further detailing करते हैं आप और उसको क्लासिफाई कर लेते हैं डिफरेंट सब प्रॉब्लम्स के अंदर और उनको फिर आप इम्प्रूव करते हैं एज वी हैव डन इन द केयर कंपेनियन रोबोट. तो आपने अपने सेमेस्टर प्रोजेक्ट्स में आई एम श्योर कि आपने स्केचेस बना लिए होंगे. लास्ट टाइम हमने कहा था कि मैंने आपको कहा था कि आपने स्केचेस बनाने 3-4 आइटरेशंस बनानी है और फिर उसके बेसिस के ऊपर आपने सिलेक्शन करनी है. व्हाट यू हैव टू डू दैट व्हाटएवर इज योर फाइनल or much better sketch that you find it really interesting, उसको आपने 3D मॉडल में ट्रांसफॉर्म करना. ऑलरेडी आप SolidWorks कर चुके हैं, use that. अगर कोई और सॉफ्टवेयर करना है, I'm not going to put restriction on it, you can use that. But in the next week, you have to do that 3D modeling of the concept that you have selected out of multiple concepts. ठीक है, ये आपने जरूर करना है क्योंकि आगे टाइम बहुत कम रह गया है and we have to cover quite a lot of bases to complete the semester project. तो this process of concept uh, evolution we have seen today. बुक के अंदर भी आपने इसको जरूर रीड करना है क्योंकि ये 3 चैप्टर्स हैं, मुख्तलिफ छोटे-छोटे हैं, लेकिन 3 केस स्टडीज भी वो साथ डिस्कस करता है. डू रीड दोस चैप्टर्स. हमने सारे कॉन्सेप्ट तो डिस्कस कर लिए हैं, लेकिन आप उसको एक बार जरूर रीड जरूर कीजिएगा. So with this, let's close this discussion today. और मैं आपको एक असाइनमेंट जिसमें मैंने आपको कहा वो भी अभी पोस्ट करूँगा, और जो आपने लैब असाइनमेंट करनी है वो मैं पोस्ट करता हूँ. Alright guys, see you next time.